MPLS Layer 3 VPN with OSPF version 2 between PE and CE. In this video, I'm going to talk about how we can configure OSPF version 2 open shortest path first between the provider edge router and also customer edge router. You know that we configured this scenario previously with static routing between PE and CE, with RIP between PE and CE, and now I'm going to show you how you can configure the OSPF between the PEs and CEs. This scenario is similar with the previous scenarios according to IP addressing and some global features such as the BGP configuration, LDP neighborships and some other things, but the new part of this scenario is the OSPF configuration between the PE and CE. But in this scenario, I'm going to configure the IP addressing, the other features of the scenario different than the other scenarios. Let me to show you how I can configure the scenario with the different, for example, function of the previous scenarios. Also, as you can see in this scenario, we are using OSPF as the IGP routing protocol of the service provider. You know that in service providers, sometimes we can use OSPF and sometimes we can use ISIS. Never we are using the EIGRP. Why? Because EIGRP doesn't support some features of the MPLS, for example, the features that we need for MPLS traffic engineering. We never using the, for example, the RIP because RIP doesn't support the features that we need. In the service providers as the IGP protocol, we are using only OSPF or ISIS. In this scenario, I'm going to use OSPF. This means that we have two OSPF process in this scenario. The first OSPF process is the OSPF process in the service provider as the IGP routing protocol, and the second or third process as the OSPF process in the PE or between PE and CE. Let me to start the configuration. After that, we can talk about the detail of the OSPF version 2. But the first question is that what is the difference between the configuration of this scenario and the previous scenario? You know that we can configure the scenario step by step, but because you are now, and I expect that you are now one master in the configuration of the IP addressing, of the configuration of the IGP inside the service provider, also a professional man or woman about the, for example, configuring BGP neighborship between the PE routers. I'm going to configure this scenario, okay, in the a total process. Means I can configure R1 with all the configuration that we need without OSPF between PE and CE, then R2, then R3 and R3. I'm not going to show you the step-by-step configuration. It is the, for example, difference between this scenario and previous scenario. Starting from router 1, let me to start you. Look at here. In router 1, the first things that we should configure is the IP addressing. Let me start with the enable conft, then hostname R1. Okay. Again, we have interface ETH00. Let me to show you with the IP address of 10.121.255.255.255.0, then no shutdown. Okay. After that, interface loopback 0 with the IP address of 192.168.2541 quad 255. This is the first things. The second things in R1 is configuring IGP. The IGP is OSPF. Let me to start the configuration of the OSPF. Router OSPF. Router OSPF1, for example, the IGP process is the OSPF process 1, and then we can use the router ID command 192.168.2541. and then we need to enable OSPF. Let me to enable OSPF in this, for example, scenario with the network statement. Also, if you want, you can configure OSPF with the commands on the interface with the IP OSPF area ID process ID. Here I'm using network 10.1.2.1 quad 0, then area 0. We are assuming that service provider now is using only one area 0, backbone area. Also, we have the second network statement 192.168.2541, again quad 0, area 0. Also, because we need the MPLS LDP, we can configure MPLS LDP from here, MPLS LDP auto config. You know that in this video, I'm going to configure with different function, not step by step. All of the configuration of the IGPs now are occurring. Also, because we are configuring MPLS LDP auto config, it's better to limit the range of the labels. MPLS label range, okay, between 100 to 199. This is a good command for troubleshooting. Also, we can configure the BGP on router 1, because now we have OSPF. This is the BGP configuration. Router BGP, the AS number of the service provider is 65,000. And also we have neighbor, the first neighbor is 192.168.2544 with the remote AS of the 65,000. If you want, you can disable IPv4 advertisement, no BGP, default IPv4 unicast. Then we configured the first neighbor 192.168.2544 with the remote AS of 65,000. Then again, neighbor 192.168.2544 with the update source loopback 0. Also, you know that we should enabling VPNv4 advertisement between these two neighbors. We can configure neighbor in the address family VPNv4 address family, okay, address family VPNv4, or for example, address family VPNv4 unicast. The command is neighbor 192.168.2544 activate. This is the configuration of R1 without the VRF definition. Let me start the configuring the VRF in R1 with the VRF definition. And here again we have two VRF, VRF-A and VRF-B. We can use VRF-A, VRF definition, for example, A or A1 if you want. A1 means the site 1 of customer A. The first command is configuring RD. Again, in this scenario, I'm using the simplest form of RD. The RD 65,000:1 is suitable, is good for the VRF-A or A1 and A2. The RD is 65,000:1, and then we can enable address family IPv4 unicast. In some iOSs, you don't have the option of unicast, but in other iOS you can use unicast, and the default value is the unicast. Address family IPv4 unicast, and then we need to configure road target. Road target, both import and export for this VRF, as I mentioned in the previous scenarios, is 65,000:1. And after that, you know that we need another VRF in the router 1 because we have two customer, VRF B1. Let me to copy the configuration of the VRF A1 here, VRF B1. And then the RD or route distinguisher is 65,000:2. Address family IPv4 unicast now is enabled, and the route target both import and export is 65,000:2 again. This is the configuration of the VRF B1. After that, we need to assign these VRFs to the interface ETH01 and interface ETH02. Interface ETH01, the first command is VRF forwarding, then for example A1. After that, we can assign IP address 10.151.255.255.255.0, and then no shutdown. This is the configuration of the interface ETH01. Also, we have interface ETH02. Then we should assign the VRF to this interface with the VRF forwarding, for example, B1. After that, IP address assignment, IP address 10.161.255.255.255.0, and then no shutdown. This is the configuration of the VRF and also VRF assignment in R1. But you know that we have another step, and this is the OSPF configuration between the R1 and PSCEs. Let me to configure this part in the, for example, next step. Until now, we configure